Hello and welcome back. In this video, we will talk about pre-training. Let's dive in. Pre-training has become a fundamental step in natural language processing. The idea of pre-training starts by training a base model over a large general database, and then by doing so, this model learns broad understanding of language, structure, syntax, and semantic. Typically, these models are trained using unsupervised or self-supervised tasks. After pre-training, we can use these models for other tasks like fine-tuning, which requires much smaller datasets. For example, word embedding. When we train word embedding, the model learns to map words to a contextual representation, which we call embedding vectors. Now, this model basically can be used later for additional tasks like, for example, classification, sentiment analysis, or name entity recognition. But what if we want to pre-train the whole model instead of just a piece of the model, which we saw in the word embedding? Now, in the modern NLP, what we do, we basically pre-train the entire model, as you can see. So later, we can use this model for additional tasks. Now, we can basically use this model for representation of the language, parameter initializations, and probability distributions. In order to pre-train basically these NLP models, one approach is to mask series of words in the vocabulary and ask the model to predict those words. By doing so, we encourage the model to learn a comprehensive information about each word, syntactically, semantically, and more. We can teach a model to learn about syntax and article choice. If we look at this example that I put fork down on the table, the model learns the correct article to fit the model context. Or co-reference resolution. For example, in the sentence, the woman walked across the street checking for traffic over shoulder, the model learns that hair refers to the woman, or semantic category learning. In the sentence, I went to the ocean to see the fish, turtles, seals, and the model predicts dolphin or whales, and additional tasks that basically these models can learn. If we talk about the pre-training of these models, generally, these language models try to predict a word given the words before that. For example, here, if we try to predict the word tasty, the model has access to the words before. And if we try to predict the word and, the model has access to all of the words before that. In general, the idea for pre-training and fine-tuning is that pre-train once, fine-tune several times. When we try to pre-train these types of models, we basically pre-train these models for a general task. That means it's next token prediction or missing token prediction. However, during the fine-tuning, we can use these pre-trained models for additional downstream tasks, for example, sentiment analysis, or document classification, or name entity recognition. How could we pre-train or fine-tune these models? Well, we can use the general approach like gradient descent or gradient ascent. The idea will be that we basically try to find the parameter theta by approximating to find the theta that minimizes the cost function. And the same idea basically we can apply during fine-tuning. We want to find a theta that minimizes the cost of the model with respect to the data set that we want to fine-tune the model over. In general, we have three types of pre-training: encoders, decoders, encoder-decoder. Depending on the task that we have, we basically could develop one of these pre-trained models. And we could also have one model like an encoder-decoder that can do both jobs, an encoder and a decoder. Well, that was it. We talked about pre-training and fine-tuning and how we can apply those to a dataset.